Greetings of the day, dear students. In the previous video, we have discussed about the common base configurations, right? We have seen what do you mean by alpha, delta IC divided by delta IE, and also we have discussed the input-output characteristics for common base configuration, and we have seen the common emitter configuration and also its input-output characteristics in the previous video. In this video, we are going to discuss about the common collector configuration. Common collector configuration. We will see what is its circuit diagram, what is its common collector NPN configuration circuit diagram, right? And also the current amplification factor gamma, which is defined as the change in output current to the input current. In this context, delta IE divided by delta IB, right? Now also we will discuss about the relationship between gamma and alpha, and finally we will see the expression for collector current, right? Dear students, with respect to the common collector configuration, right? So here this is the emitter, and this one is the base, and this is the collector. Collector is common to both the input and output terminals. For input and output terminals, collector is common, right? Similarly, if you observe in PNP configuration, so this is the emitter and this one is the base and this is the collector. Here also collector is common to both the input and output configuration, right? Now in NPN configuration, where this is emitter is N, this is N, and this is P, and again this collector is of N type, right? Now the base is connected to the positive terminal and the collector is to be connected to the negative terminal. Similarly, the emitter is connected to the negative terminal, and the collector is connected to the positive terminal in NPN configuration. Whereas in PNP configuration, for example, the collector is P type and the base is N type, right? And again the emitter, here emitter is P type, right? Now the base is connected to the negative terminal and the collector is connected to the positive terminal, whereas the emitter is connected to the positive terminal and this collector is connected to the negative terminal. This is how we have to draw the circuit diagram for common collector NPN configuration and for common collector PNP configuration. So it is defined as the collector will be common to both the input and output. Now input current is the base current and output current is the emitter current. So now its ratio, the current amplification factor is defined as the change in output current to the change in input current. Here in this context, the output current is emitter current, so delta IE divided by delta IB. Now the circuit provides the same gain as common emitter configuration, right? So delta IE is approximately equals to the emitter current is almost approximately equal to the delta IC. Delta IE is approximately equal to the delta IC. So here we have defined gamma as delta IE by delta IB, but alpha is already defined, the delta IC by delta IE, and from our transistor previous basics, the emitter current is equals to the base current plus collector current. A small change in emitter current is equals to the delta IB plus delta IC. If you further simplify, delta IB can be written as delta IE minus delta IC. But whereas in the place of delta IB in this gamma equation, if you substitute delta IE minus delta IC, you will get gamma equals to delta IE divided by delta IE minus delta IC. So now let me take out delta IE common. Therefore delta IE by delta IE whole divided by delta IE by delta IE minus delta IC by delta IE. So this numerator part becomes 1 divided by 1 minus. Already this variable we have defined earlier. This is nothing but alpha. Therefore gamma equals to 1 by 1 minus alpha. Very, very important. Whereas if you observe, we have derived beta also. The relationship between beta and alpha is also derived. There we got beta equals to alpha by 1 minus alpha. These two derivations are very, very important. Gamma equals to 1 by 1 minus alpha. Beta equals to alpha by 1 minus alpha. Clear? Now as we are from our previous basics, delta IC equal to delta IE plus delta ICB naught, where ICB naught indicates the reverse current, leakage current due to the minority charge carriers across the collector and base junction, right? The collector current is written as alpha times emitter current plus leakage current ICB naught. Therefore in the place of IC, if we substitute alpha IE plus ICB naught, we will get IE equals to IB plus alpha IE plus ICB naught. Now if you take out IE is taken out common, right? IE bracket of 1 minus alpha equal to IB plus ICB naught. So therefore IE emitter current equals to IB by 1 minus alpha plus ICB naught by 1 minus alpha. But 1 by 1 minus alpha is nothing but gamma, right? And further simplification, 1 by 1 minus alpha is nothing but beta plus 1. Beta plus 1 is nothing but 1 by 1 minus alpha. So in the place of 1 by 1 minus alpha, he has substituted beta plus 1. Therefore emitter current equals to beta plus 1 times IB plus beta plus 1 times ICB naught. So this is what all about the common collector configuration. So with this we have completed the common emitter, common base and common collector configurations for transistor. Clear? We have started with common base. So we have completed all these topics in the previous videos. Okay students, thank you.